Today we will look at carbohydrates and lipids. Both of these macromolecules are composed solely of carbon, hydrogen, and oxygen. Most macromolecules are polymers. These are long molecules consisting of many similar building blocks called monomers. When many monomers are attached together, they make what is known as a polymer. The prefix poly means many. Carbohydrates, proteins, and nucleic acids are all polymers. The only exception is that lipids are not. Macromolecules are made by a dehydration reaction. This is where monomers are joined by losing a water molecule. Polymers are broken down into monomers by hydrolysis. This is the reversal of a dehydration reaction. Carbohydrates are broken down into two groups, simple and complex. Simple carbs are found in fruits, milk, vegetables. Cake and candy are refined simple sugars. They provide energy, but they lack the vitamins, minerals, and fiber. Simple carbs raise blood pressure and digest much faster. They are for short-term energy bursts and should come to no surprise, usually taste better. Complex carbs are high in fiber and digest slower. They provide consistent energy throughout the day. Complex carbs are the good carbs we should be eating to maintain a healthy lifestyle. All simple carbs are sugars that end in ose, O-S-E. This is how you know it's a sugar. Examples include glucose, sucrose, galactose, maltose, ribose, deoxyribose. Glucose is a sugar that comes from the foods we eat. High amounts of glucose in the blood is what leads to diabetes. Cells in the body take in glucose and use it as an energy source. It is also the most important sugar to all living things. Again, this is our main energy source. You do need to know its formula, C6H12O6. Glucose is further classified as a monosaccharide, meaning it is made of one sugar. A characteristic of sugars is that they also form rings, as you can see in the structure in the top left corner. Another indication that it is a sugar is that it has a 1:2:1 ratio of carbon to hydrogen to oxygen. So if you look at the formula C6H12O6, you'll see carbon and oxygen are equal and hydrogen is twice as much. This is true for all sugar formulas. Disaccharides are simple sugars made of two rings, or two monosaccharides. Three examples are shown. Sucrose is made from glucose and fructose, which are both monosaccharides. There is also lactose, which is known as milk sugar, and maltose, which is known as malt sugar. The last group we have are known as complex carbs. These are polysaccharides because they are made up of many sugars. Poly means many. So if you have more than two, which is a disaccharide, you end up with a polysaccharide. These long chains of glucose provide energy storage and structure for some living things. We refer to these as starches. Starch is a storage polysaccharide of plants. These consist entirely of glucose monomers. As you can see with the vertical structure on the right, that is a very complex structure. Plants store surplus starch as granules within their chloroplasts. Glycogen is also referred to as animal starch because this is how humans and other vertebrates store their carbohydrates. We store it mainly in our liver and muscle cells. Polysaccharides are also involved in plants having their structure. Cellulose is a major component of the cell wall of plant cells. This is what allows plants to stand erect towards the sun. So let's recap. All carbohydrates are made from sugar rings. Those sugar rings can be either classified as a monosaccharide made of one, a disaccharide made of two, or a polysaccharide made of many. I did fail to mention that saccharides is the root word for sugars. Lipids are a concentrated energy molecule used for long-term storage. This is what makes it difficult to lose weight versus packing on the weight. The building blocks that form lipids are fatty acids and the glycerol backbone. Examples of lipids include fats, oils, waxes, and steroids. Humans and other mammals store their fat in adipose cells, known as lipocytes, which expand in size until the fat is used for fuel. Adipose cells also cushion vital organs and insulate the body. A fat molecule is not a polymer, just a very big fat molecule. The gray region indicates the glycerol backbone, and the three yellow vertical are the fatty acid tails attached to the backbone. Most lipids are known as glycerides. If the glycerol backbone has one fatty acid tail, it is a monoglyceride. Two is a diglyceride. And if there are three fatty acids attached, then it is a triglyceride. If the fatty acid tail is completely surrounded by carbons, like the top diagram, it is referred to as a saturated fatty acid. If there are double bonds anywhere in the fatty acid tail and is not completely surrounded with hydrogens, it is known as an unsaturated fatty acid. We will look at examples of both of these during class today. Steroids are a special group of lipids that don't have anything to do with the glycerol and the fatty acid tails. Instead, it is characterized by the four fused rings. How it differs from carbohydrates is that these rings are sharing one of their sides. They're not linked together like they're holding hands. They are rather fused. Cholesterol is an important steroid that plays a role in animal cell membranes that we will learn about next unit. Although cholesterol is essential in animals, high levels in the blood may contribute to cardiovascular disease. Another special group of lipids are phospholipids. They are the major component of all cell membranes. We will learn all about the phospholipid bilayer in Unit 3. That wraps up carbohydrates and lipids.